In the last couple of lessons, we've had a bit of a mess around with logarithms. So we've manipulated them, solved them, combined them, etc., etc. So today what we'll do is start to graph them. So I think it's important to note that we kind of do already know what the graph of the logarithm looks like. Remember the video we watched with Hannah Fry explained Weber's law. So we know that the graph is going to look like that. But important to note that the logarithm or the graph of the logarithm is the inverse of the exponential. Okay, so let's just have a look at what the graph is going to look like. So we've got f of x equals 2 to the x, and these notes want the inverse of f of x. So we'll write down y equals 2 to the x. Now to remember, to invert a function, what we're doing is we're reflecting along the line y equals x, and the reason for that is that we swap the x and the y values. So x equals 2 to the y. Now my question is, can we rewrite this in such a way that y is the subject? And we certainly can, it's the logarithm. So we're going to go log 2 and x is equal to y. So f negative 1 of x is equal to log 2x. All right, so let's have a look at some of the points. The point 1, 2 is on the graph of f of x equals 2 to the x. So that means the point 2, 1 is on the graph of the inverse. So f negative 1 of x equals, I presume they just want us to write log 2x there, is on the graph of f negative 1 of x is log 2x. Now, why is that? Or let's just test it if you don't sort of believe me. What we'll do is we'll ask it, so if f of x equals log 2x, we're just going to go, what would be f of 2? Okay, and the log function should produce 1 as an answer. So it's log 2, 2. 2 raised to what power will return itself? The answer has to be 1. So therefore 2, 1 is a point. All right, so let's mark that one in. All right, now there's a horizontal asymptote with the equation. So this is on the exponential. There's a horizontal asymptote along this line here. All right, and that's the line y equals 0. Okay, now if you sort of think about it, the log function will have an asymptote because we swap x and y. So we're going to say that there is a vertical asymptote with the equation x equals 0. Okay, so we still haven't drawn the actual logarithm yet, but let's add the vertical asymptote and x equals 0. Right there. All right. Now, what else do we know? Well, so notice how 2 to the x has a y-intercept when x is 0, y is 1. So the y-intercept is when x is 0, y is 1. That means that the x-intercept is going to be 1, 0. All right, so let's pop that in, 1, 0. Okay, so here our y-intercept is 0, 1. Again, when we swap x and y, it becomes 1, 0. All right, the domain of the exponential is the set of all real numbers. The range is 0 to positive infinity, or real positives, you could say. So that's that. Now, the domain and range then for the inverse, they will just swap. Okay, so the domain should be 0 to positive infinity, and the range should be the set of all real numbers. Okay, so again, we know that the graph is going to look like this. All right, so that sort of makes sense. Is a one-to-one function. Okay, f negative 1 of x equals log 2x will also be a one-to-one function. All right, so without further ado, I think we have a stab at drawing this thing. So come through there and something like that, remembering that it should be or look reflected along that line there. Okay. Similarly, the function y equals log e x is the inverse of y equals e to the x, okay? And you'll often see it written as y equals ln x, okay? So we call that the natural logarithm. So we'd see y equals ln. I don't write it like this, but that's the way some people write it, as ln x. But just a reminder that when we write our logarithms, if it's base e, we need to write that base, or whatever the base is, we need to write that base nice and low. Okay, so you can't write this log e, all right? That is frowned upon a little bit. All right, so let's do some sketches. So what we're going to do is label the asymptote, label axes, intercepts with coordinates, state the domain, and also talk about the transformations. All right, so this log graph here, we immediately can see that it's gone to the right 3 units. Okay, so let's note that there is a translation, 3 units right. So that means we're going to pop the asymptote 3 units to the right as well. So that's going to be x equals 0. So we know that the log then is going to go like this. So it's just the standard logarithm, which looks like this. And we're just going to shove that thing 3 units to the right. So let's get the y-intercept. So the y-intercept, the x-intercept rather, occurs when y is equal to 0. So we'll go 0 equals log 2 x take 3. All right, so what we need to do is get that out of log form so that we can solve for x. So we're going to go 2 to the 0 equals x take 3. Now 2 to the 0 is 1. X equals 4, which should make sense because that means that the x-intercept of the standard, which is 1, 0, should move 3 units to the right. So it should be 4. So let's get our scaling right. This is 1, this is 2, this is 3, this is roughly 4. All right, so go ahead and draw it. We'll just leave the y-axis blank so we're not committing to any values. Okay, this one here, so what's going to happen is we're reflected in the x-axis and we're up 1 unit. Okay, so our transformations are reflected in x-axis and translation 1 unit up. All right. Now, because it hasn't moved left or right, that's the key piece of information. So there's no horizontal translation. That means the asymptote stays put right there. Also means that there's no y-intercept. So it's at x equals 0. For the previous question, I'm supposed to state the domain and range. Dom is 3 to positive infinity. And range is R. Okay, back to this one. So the translation up 1 unit, I'm not really worried about that because when I find the x-axis intercept, that will sort of sort that out. So x-intercept occurs when y is equal to 0. So I'm going to go 0 equals negative log, what was the base? 10 x plus 1. All right, so I'm going to subtract 1 and dump the negative. So I'm going to get 1 equals log 10x. Okay, let's switch forms. So we'll go 10 to the 1 equals x, x equals 10. So that seems right. So let's pop that in. So I'll pop in a 10 there. And basically, because of this negative here, again, this is what the standard logarithm looks like. So reflection in x means it's going to look like that. So let's bring it down through there and send it off in that direction. The DOM is R positive, okay, or 0 to positive infinity, not inclusive of 0. The RAN is R. Okay, this one. All right, so to quote the transformations, what we need to do is get it to what we call single x, or what I called single x at the start of the year. So we're going to go write this as y equals log e negative 2x take 2. All right, so now we can quote the transformations. So we can do that in Dr. T order now that we've got coefficient x1. So we can say reflection in y okay, so that's that thing there. We can say dilation half from y-axis, so that's the 2 there, and then we can say that x take 2 is a translation 2 units to the right. Okay, so it's the 2 units to the right that I'm probably most interested in, to be honest, because they form the basis of the asymptote. So that is going to be x equals 2. Now, because it's reflected in the y-axis, here's the standard. When I reflect in the y, it's going to look like that. So our log is going to look like that. So that means that we're definitely going to get a y-intercept and an x-intercept. All right, so let's find out what they are. Oops. So I'm just going to do my working out down here. All right, so there's my function. So let's first of all get the, what do you want to get first? We'll get the y-intercept, because when x is equal to 0. So the y-intercept is going to be sub x equals 0, y equals log e4. Now if e is 2.7, 2.7 to the 1 will be 2.7, or e. So it's going to be somewhere between 1 and 2, log e4 is. All right, x-intercept sub y equals 0. So we're going to go 0 equals log e4 take 2x. E to the 0 equals 4 take 2x going into exponential form. 1 equals 4 take 2x. Negative 3 over negative 2 equals x. X is equal to 1.5. Okay, so here's 2, here's 1, here's 1.5. So 3 on 2 comma 0. So what we're going to do is run it through there, and we'll just mark the y-intercept with the log e4 value. So bring it through. That'll do. And so when x is 0, y was log e4. Remember, you can use ln if you want. VCAR don't use ln. Okay, so see how we've written log e4? You could write ln4. I don't do that. VCAR doesn't do that, but you're well within your rights to do that. Again, the point I want to hammer is that you're not allowed to write this as log e, or loge, as I've heard VCAR examiners call it. Okay, the final one is this one here. So we've got a translation 1 unit left and 2 units down. So it's the one to the left that I'm interested in. X equals negative 1. All right. So you can see that it's going to go this way. So we're going to get an x and a y-intercept. So good to know. So f of 0 equals, now, so when I jam 0 in, I'm going to get log e1. Now log e1, e raised to what power will give us 1? That's 0. Okay, so that's going to be 0. So f of 0 is negative 2. So that basically is saying that the y-intercept is -2. Okay, so we can see we're going to come up and go through here somewhere. All right, so where is that going to be? So we're going to go 0 equals log e x plus 1 take 2. Take away 2. Ugh, worst memory, -2. Ugh. Okay, 2 equals log e x plus 1. E to the 2 equals x plus 1 going into exponential form. X equals e to the 2, take away 1. So again, that value should be gettable. I'd approximate e to be 3. 3 squared is 9. So this is going to be a bit less than 9. And we're going to remove 1 from a bit less than 9. So if we guessed 8 or 7 or something like that, that would be, you know, a reasonable guess. Let's just see how close I was. E to the 2, take away 1. Okay, 6.4. So I wasn't particularly close, but yeah, good enough. So what we're going to do is send it through there. Now this is -1, so it's going to have to be a fair way along to be scaled correctly. So what I might do actually is just be a bit cheeky. I'm going to lower the y-intercept down to here. And let's go through. Yeah, so that sort of seems around about 6.4, which seems roughly appropriate. So when x is equal to, so what was it? Log e. Oh, I can't remember. What was the x-intercept? E squared take away 1. The y value is 0, 0, -2. All right, range and domain. So the domain was -1 to infinity, I think. Yeah. And the range is all reals. I don't think I put the range and domain for this one, so let's just note that the domain is going to be -infinity all the way up to the asymptote, which is 2, and the ran is r. Okay. All right, we'll finish with a few quick inverses. Okay, so when we invert, or before we invert, let's just note that the domain of this logarithm, so it's 4 to the right, dilation doesn't matter, so this is what the picture looks like. So the domain is going to be 4 to positive infinity, the ran is r. Okay, so we're noting that down because what we're going to do is let y equal to log 3 x take 4, swap x and y, x equals 2 log 3 x take 4, x on 2 equals log 3 x take 4. Okay, now we're going to switch to exponential form. So we're going to say 3 to the x on 2 equals x take 4. Ooh, hang on. I should have swapped x and y, and I've got 2 x's. So change that, and change that. It's always a bad sign when you're trying to solve for y and there is no y. Okay, so y equals 3 to the x on 2 plus 4. All right, so our conclusion, f -1 of x equals 3 to the x on 2 plus 4, where x is an element, all right, and because the range is all reals, the domain of this is going to be all reals. Okay, so the inverse of a logarithm is an exponential. Guess what the inverse of the exponential is? Well, it's got to be a logarithm. So let's go dom is r, okay, because that's just a 3 to the x function gone up 1 unit. And our range is going to be 1 to positive infinity. Let y equal 2 times 3 to the x plus 1. Swap x and y. X equals 2 times 3 to the y plus 1. I did it right this time. Okay, we're going to go x take away 1 on 2 equals 3 to the y. Ooh, how do I make y the subject? Well, let's switch to log form. Log 3 x take 1 on 2 equals y. That means g negative 1 of x equals log 3 x take 1 on 2, where x is an element of 1 to positive infinity. All right, so there it is. All right, so our inverse, if that's our original, our inverse is going to look something like that. All right, so after a fairly long 21 or 22 minute video, it's not that many questions, so get stuck into those, and I'll catch you guys later in the week.